Hi guys, and welcome to another Mr. Pollock biology video about membranes and transport. This video is going to be about transport across the membrane, how we get stuff into and out of the cell. This is for AQA students studying A-level biology. This is from the AS section, Unit 1, Biology and Disease. Let's have a look at our objectives for today. We're going to know the three types of transport and know the key characteristics of each. We'll also have a little look at Fick's law as well. Let's start by looking at simple diffusion. So here's my phospholipid bilayer, and here are some small uncharged molecules, possibly oxygen, maybe not, but possibly oxygen. Now simple diffusion is dead straightforward. It's movement from a high concentration to a low concentration. There we go, the particles have moved from where there was lots of them to where there weren't very many of them. It's dead straightforward. So here are the key characteristics. It involves movement from a high concentration to a low concentration. We don't need a carrier protein, we don't need any external energy, it happens passively, and it usually occurs in very small or lipid-soluble molecules. So a very small molecule might be a gas like oxygen, and a lipid-soluble molecule might be something like a steroid. Moving on, we'll look at facilitated diffusion. Now facilitated diffusion has much in common with simple diffusion, except it requires these things called carrier proteins. And here we see that these larger molecules move through the carrier proteins. Still we're moving from high concentration to low concentration, but the only difference is that these carrier proteins are required to allow these large or charged molecules to pass across the membrane. So some key features here. Again, high concentration to low concentration. This time we need a carrier protein, and no energy required. And this is used to transport large, like glucose, or charged, like ions, across the cell membrane. Finally, we're going to look at active transport. So same story again, we've got the phospholipid bilayer, carrier protein, and here are our molecules that we want to move. Now this time we're going to be moving from low concentration to high concentration, so from the bottom to the top. Now to do this we need some energy, and to supply that energy we have this useful molecule called the energy currency of the cell, which is called ATP, or adenosine triphosphate. And it's going to come and it's going to bind to the carrier protein. And this effectively changes its shape ever so slightly. And as it does that, it becomes ADP, or adenosine diphosphate, giving out a small amount of energy that was stored in the bond between some of the phosphates on the ATP. Now as it does that, it allows one of these molecules to be transported across the membrane because of the changed shape of the protein. Once it's done, the ADP is going to move away, and this can repeat. So to summarize active transport, it's from low concentration to high concentration. We need a carrier protein, we need energy in the form of ATP, and it's for large or charged molecules. And usually these are high value or dangerous molecules. So by high value I mean things like glucose, that we want to get as much as possible into the cell. And by dangerous or toxic molecules I mean things like urea or waste, things we want to get rid of quickly. So it's also useful to understand something called Fick's law, which determines the rate of diffusion. So diffusion, the rate of diffusion is determined by the surface area multiplied by the concentration gradient divided by the diffusion distance. So anything on top is better if it's bigger. So it's better to have a large surface area, it's better to have a large concentration gradient because that's going to give us a big number on top. Conversely, the stuff on the bottom, we want smaller is better. So a smaller, short diffusion distance means that that diffusion is going to happen really quickly. So ideally you want large surface area, huge concentration gradient, and tiny diffusion distance. Other things will affect the rate of diffusion as well. So if we're thinking active transport or we're thinking facilitated diffusion, it's useful to have more carrier proteins. And temperature also will affect this. The more temperature, or the higher the temperature, the more heat means the more kinetic energy particles will have. Therefore they'll move quicker. Let's summarize this then. So simple diffusion involves the movement of high concentration to low concentration. Facilitated diffusion involves movement from high concentration to low concentration using a protein carrier, and active transport requires ATP, that's energy, and a protein carrier to move stuff from a low concentration to a high concentration. And that's it until we look at osmosis. So thanks very much, guys. Like, comment, and subscribe.